We are going to start now lecture 9 of chapter 9 class 11th mathematics, sequence and series. So in this lecture we will discuss about two things. First is the n geometric mean between two given numbers, and second is the sum of infinite GPs. So the first formula we have over here, it is the n geometric mean between two given numbers. So suppose we are given two numbers a and b, and we want to insert n geometric mean between them. N geometric mean means we are talking about g1, g2, g3, so on up to gn. These are the n different numbers we have. These are the n numbers we have, and we want to insert these n numbers between a and b such that this new sequence, it is a GP. So to find these numbers, we are saying for this new GP, we have the first term, it is a. The number of terms we have, it is n plus 2. The last term we have, it is b. So if we write the value of t n plus 2, we are saying it is equal to b, and the value for this term, it will be a r raised to the power n plus 1. So this implies us that the value of r is b by a raised to the power 1 by n plus 1. So now if we write the value of g1, the first geometric mean, the answer we have, it is ar. So it is equal to a into b by a raised to the power 1 by n plus 1. If we write the value of g2, the answer we have, it is ar square, that is a into b by a 2 by n plus 1. And continuing in this way, if we write the value of gn, we have a r raised to the power n, that is equal to a into b by a raised to the power n over n plus 1. So these are the values for the n geometric means inserted between the numbers a and b. So based upon this, the first question we have is insert two numbers between 3 and 81 so that the resulting sequence is a GP. So we are saying the new GP we will have, it is this first term is 3, second last is 81. We are inserting two numbers g1 and g2. So now the total terms we have, it is 4. So we are writing 81 is equal to a r raised to the power 3. So this implies us that the value of r cube is equal to 27, and this implies us r is equal to 3. So the value of g1 we have, it is 3 into r, that is equal to 9. The value of g2 we have, it is 3 into r square, that is equal to 27. So these are the two geometric means g1 and g2. These are the two geometric means between 3 and 81. Next is insert three numbers between 1 and 256 so that the resulting sequence is a GP. So again we are saying the first term, it is 1, this is 256, and we have to insert three numbers. We are saying it is g1, g2 and g3. So we have total 5 terms. So we are writing 256 is equal to a into r raised to the power 4. So this implies us that the value of r we have, it is equal to 4. So from this what we obtain is that the value of g1 is equal to 1 into 4 is equal to 4. The value of g2 is equal to 1 into 4 square is equal to 16. The value of g3 is equal to 1 into 4 cube is equal to 64. So these are the required 4 numbers, 4, 16 and 64. These are the required 3 numbers which are the geometric mean between 1 and 256. Next is, if G be the geometric mean between two given numbers, A1, A2 be the two arithmetic means between them, we have to prove this result. So if G is the geometric mean between these two numbers, we are saying G is equal to A into G square is equal to A into B. A and B we are considering two numbers, and A1 and A2 be the two arithmetic mean between them. So if A1 and A2 are the two arithmetic means, if we are saying A and B is there, then we have A1 and A2. So this forms an AP. This is an arithmetic progression. So we can write from this result, this implies us, this is A1 and this is A2. So this implies us that 2 times A1 is equal to A plus A2, and 2 times A2 is equal to A1 plus B. Now from this first equation, we have A is equal to 2 times A1 minus A2, and this second equation implies us B is equal to 2 times A2 minus A1. Now if we substitute these values in this given equation, we obtain G square is equal to 2 times A1 minus A2 into 2 times A2 minus A1, and this is what we have to prove. Next is, if A1, or we are saying A is the arithmetic mean and G1, G2 are the two geometric mean between two numbers, then we have to prove this result. So A is the arithmetic mean, it means we are saying that A plus B is equal to 2 times A. G1, G2 are the geometric means. So we have the numbers A, G1, G2 and B. These numbers, they form a GP. So this implies us that G1 over A, that is equal to G2 over G1, and G2 over G1 is equal to B over G2. So this first equation, this implies us that the value of A is G1 square by G2, and the second equation implies us the value of B is G2 square by G1. Now if we substitute both these values in this first equation, the answer we get, it is G1 square by G2 plus G2 square by G1 is equal to 2 times A. We obtain this final result. Next is infinite geometric series. We are talking about the sum of infinite geometric series. So infinite geometric series means we are saying the elements we have, it is A1, A2, A3, so on up to infinity. Or we are writing it is, the first term is A, next is AR, next is AR square, next is AR cube, and so on. So this is the geometric, infinite geometric progression. And if we add all these terms, it is A plus AR square plus AR cube and so on, we add all these terms. This is called the infinite geometric series. The sum we are taking, it is up to infinite terms. Now we have to prove that if the first term of an infinite GP is A and the common ratio is R, and this condition is important over here, that the value of mod of R is less than 1, then the sum of this GP, it is given by A over 1 minus R. Now we are saying, we have already seen that the sum of the finite number of terms Sn, the formula we know, it is A into 1 minus R raised to the power n over 1 minus R. So we can write this is equal to A over 1 minus R minus AR raised to the power n over 1 minus R. Now if we take the limits we will see in our next chapter. Right now you can just understand in this way. Limit means we are saying, we are talking about limit n tends to infinity. You can understand in this way, we are saying that when the value of n approaches to infinity, when we start increasing the value of n, we are getting, it is Sn. This is equal to, this will become S infinity, sum of infinite terms, that is equal to A over 1 minus R, this term is independent of n, minus limit n tends to infinity, AR raised to the power n over 1 minus R. Now look at this term over here, we are talking about this term, limit n tends to infinity, R raised to the power n, and the value of R, it is being given that mod of R is less than 1. So we are saying if mod of R is less than 1, we are substituting the power 1, we get it is R. Then we know that this R will be greater than R square. that will be greater than r cube, that will be greater than r4, that will be greater than r5. This is the case only when we are saying that mod of r is less than 1, and it will keep on going like this. So we are saying that when n approaches to infinity, if we talk about the infinite number of terms, these terms will tend toward 0. It means limit n tends to infinity, r raised to the power n is 0. More details you will be able to understand when you will study the chapter of limits. Over there you will be able to understand in a much better way that how this limit is being taken. So right now you can just understand in this way that this value will become very small, and we are saying that this term, this r, because of this r raised to the power n and n is tending to 0, this term will tend to 0. So this whole term will become 0. So the answer we are getting in this case, it is the sum of infinite GP. It is a over 1 minus r. The sum of infinite GP, it is a over 1 minus r. So the first question we have now based upon this is find the sum of infinite series this. So if we calculate the value of r, it is 1 by 3 by 1 is equal to 1 by 3, and it is less than 1. So we are saying this is convergent. This we will have the sum over here, the series is convergent, and the answer we will have the value of a, we have it is 1. So the sum of infinite series we have it is a over 1 minus r, that is equal to 1 over 1 minus 1 by 3. The answer we get it is equal to 3 by 2. Next is find the sum of infinite geometric series this. So in this case we have the value of a is 1 and the value of r is minus 1 by 3. So the sum of infinite terms will become 1 over 1 minus 1 by 3. The answer we obtain that is equal to 3 by 4. So the sum of this series is 3 by 4. Next is find the sum of infinite geometric series. It is minus 5 by 4 is the first term, and the value of r we have it is 5 by 16 divided by minus 5 by 4. So on solving this we will get this is equal to minus 1 by 4. So what we get is that mod of r is less than 1. So this geometric series it is convergent, and the sum of this series is given by minus 5 by 4 over 1 minus r. The value of r is minus 1 by 4. So the answer we obtain it is minus 5 by 4 into 4 by 5, that is equal to minus 1. So the sum of this geometric series it is minus 1. Next is find the sum of the infinite geometric series this. So the first term over here, in this case the first term we have, it is equal to root 2 plus 1. The common ratio r we have it is 1 over square root of 2 plus 1. So if we rationalize this value of r, we are getting it is root 2 minus 1 over root 2 minus 1. We have multiplied, the answer we get it is root 2 minus, the value of r we have it is root 2 minus 1. A we have it is square root 2 plus 1. So the sum of this series it is a, that is root 2 plus 1 divided by 1 minus r. So it is 1 minus root 2 plus 1. So the answer we get it is square root 2 plus 1 over 2 minus root 2. And if you rationalize this term, it is 2 plus root 2 divided by 2 plus root 2. The answer you will obtain it is 4 plus 3 root 2 divided by 2. So this is the answer in this case. Now next is this series is given. It is not being given that this is a geometric series, and it is clear from the fact that if you divide these two values you will have the answer 1 by 3 square into 2, that is equal to 2 by 3 square. Whereas if you divide these two terms, the answer you will get it is 3 square by 2 square. So this is not a geometric series. Now if we are saying that if it is possible to find the sum of this infinite series, we are assuming that it is possible to find the sum of this infinite series. So we are saying that we can rearrange the terms of this series. So if we rearrange these terms, we are getting it is 1 by 2 plus 1 by 2 cube plus 1 by 2 raised to the power 5 plus so on up to infinity. We are rearranging the terms, and there are certain conditions for the rearrangement that we have, that we are not going to discuss at this stage. At this moment you can just understand in this way that the sum of this series exists. That is why we are rearranging the terms to find that sum. And the other part we are writing it is 1 by 3 square plus 1 by 3 raised to the power 4 plus so on up to infinity. Clearly both of these, now these are the geometric series separately, and the first sum of this geometric series, this first series, we are saying the first term it is 1 by 2, the common ratio we have it is 1 by 2 raised to the power 2, then it is plus 1 by 3 square divided by 1 minus 1 by 3 raised to the power 2. So the answer we obtain in this case, it is when you solve this term, you will get it is 3 by 4. When you solve this term, you will get it is 8 by 9. So the answer we are getting it is 1 by 2 into 4 by 3 plus 1 by 9 into 9 by 8. So this is equal to 2 by 3 plus 1 by 8, that is equal to 19 by 24. So the answer we are getting it is 19 by 24. Next is prove that 6 raised to power 1 by 2, 6 raised to power 1 by 4, 6 raised to power 1 by 8, so on up to infinity is equal to 6. So it is power over here. So what we can obtain from this is, we are talking about 6 raised to power 1 by 2 plus 1 by 4 plus 1 by 8, so on up to infinity. We are talking about the left hand side is equal to this. Look at this power. This is an infinite GP. The first term is 1 by 2, 1 minus 1 by 2. The answer we obtain it is equal to 1. So we are saying that this term is equal to 6 raised to the power 1 is equal to 6, that is equal to right hand side, that is equal to RHS. Next is, if mod of R is less than 1, the common ratio it is given to be less than 1, and the value of X is given to be A by R square and so on up to infinity. The value of Y is given to be B minus B by R plus B by R square, so on up to infinity, and the value of Z is given in this way. We have to prove this result. So we are writing first the value of X. The value of X we will have it is, A is common, we are left with is 1 by 1 plus 1 by R plus 1 by R square and so on up to infinity. Now the sum of this series will be A into, first term is 1 over, the common ratio we have it is 1 by R. So the answer we obtain it is A R over R minus 1. For this second series we have Y is equal to B into 1 minus 1 by R plus 1 by R square and so on. So we get it is B R over R plus 1. And for this third series, we are saying Z is equal to C into 1 plus 1 by R square plus 1 by R raised to the power 4 and so on up to infinity. So we are getting it is C into 1 by 1 minus 1 by R square. So we are getting it is C R square over R square minus 1. Now if we calculate the value of X, Y over Z, we are calculating the value of X, Y over Z. The answer we obtain it is A R over R minus 1 into B R over R plus 1 into R square minus 1 over C R square. So this R minus 1 gets cancelled over here. These R square get cancelled and we are left with is A B over C. So we are getting the final answer in the form that X Y over Z, this X Y over Z, that is equal to A B over C. Next is, if Y is equal to X plus X square plus X cube so on up to infinity, and it is given that mod of X is less than 1, we have to prove that X is equal to Y over 1 plus Y. So we are writing Y is equal to X plus X square plus X cube so on up to infinity. This is an infinite GP. So the answer we obtain this for this, it is equal to x over 1 minus x. It is given that x is less than 1. So we are saying this series is convergent, and we are getting the answer as x over 1 minus x. Now we want to calculate the value of x. So we are writing y minus y into x is equal to x. This implies us y is equal to x plus xy. This implies us y over 1 plus y is equal to x. So this is the final answer we obtain in this case. Next is, if x is equal to 1 plus a square so on up to infinity, a is given to be less than, mod of a is given to be less than 1, y is equal to 1 plus b square so on up to infinity, mod of b is less than 1. We have to prove that 1 ab square so on up to infinity is equal to this value. So clearly this is a GP, and the sum of this GP is 1 over 1 minus a. This is the value of x. The value of y we have, it is 1 over 1 minus b. Now if we calculate the value of xy over xy minus 1, we are talking about this term, we will get it is 1 over 1 minus a into 1 over 1 minus b divided by 1 over 1 minus a plus 1 over 1 minus b minus 1. So if you multiply all these terms, if you solve this value, you will obtain, it is, you take the, I am talking about this denominator part over here, we have 1 minus a into 1 minus b is the LCM, and what we are left with is, this 1 minus a 1 minus b gets cancelled over here, and we are left with is 1 over, at this point we will have 1 minus b, then we will have plus 1 minus a, and then we will have minus 1 minus a into 1 minus b. On solving this, we will obtain this is equal to 1 over 1 minus ab. Now look at this value, we are talking about 1 over 1 minus ab. This is equal to 1 minus ab raised to the power minus 1, and this is equal to 1 plus ab plus a square b square plus so on up to infinity. This is basically the part of the combinations. We have already a binomial theorem, we are saying by using the binomial theorem we have expanded this value and we obtain this result. So we have proved that this value is equal to xy over x plus y minus 1. Next we have is, if the value of x is equal to 1 plus r raised to the power a plus r raised to the power 2a so on up to infinity, y is equal to 1 plus r raised to the power b, r raised to the power 2b so on up to infinity. So from this result we have x is equal to 1 over 1 minus r raised to the power a. From this result we are writing y is equal to 1 over 1 minus r raised to the power b. Now if we substitute or we try to find the value of r raised to the power a from this equation, we will obtain that 1 minus r raised to the power a is equal to 1 by x. So r raised to the power a is equal to 1 minus 1 by x. Similarly from this second equation, from this equation we are saying, we obtain that r raised to the power b is equal to 1 minus 1 by y. So combining both these results, what we get is that the value of r is 1 minus 1 by x raised to the power 1 by a, that is equal to 1 minus 1 by x raised to the power 1 by b. So it is x minus 1 by x raised to the power 1 by a, and it is x minus 1 by x raised to the power 1 by b, and this is what we have to prove. Next is, use the geometric series to express 0.555 so on up to this as 0.5 bar as a rational number. So we are writing 0.5 plus 0.505 plus 0.005 plus so on up to infinity. We can write this is 5 by 10 plus 5 by 10 square plus 5 by 10 cube plus so on up to infinity. We can write this is 5 by 10 common, we are left with this 1 plus 5, 1 by 10 plus 1 by 10 square plus 1 up to infinity. This is an infinite GP, and the answer we obtain it is 1 over 1 minus 1 by 10. So that is equal to 5 by 10 into 10 by 9. So the answer we obtain it is 5 by 9. We are able to calculate the sum over here because the value of mod of r, that is less than 1. Next is find the rational number whose decimal form is 0.14 bar. So we are writing 0.142 bar, that is equal to 0.1424242 and so on. And suppose we are writing this is equal to x, or we are writing this is equal to 0.1 plus 0.42 plus 0.0042 plus so on up to infinity. So it is 1 by 10 plus 42 by 10 cube plus 42 by 10 raised to the power 5 plus 42 by 10 raised to the power 7 and so on. It is 1 by 10 plus 42 by 10 cube common. We are left with is 1 by 10 square plus 1 by 10 raised to the power 4 and so on. This is an infinite GP, and the sum of this GP it is 1 over 1 minus 1 by 100. So the answer we get it is 100 by 99. So on solving this we obtain it is 1 by 10 plus 42 by 1000 into 100 by 99. So these values gets cancelled and we are left with is 1 by 10 plus 42 by 990. Answer we get it is 141 by 990. So this is the rational numbers whose decimal form is 0.142 bar. Now next we have is find the rational number whose decimal form is 1.345 bar. So we can write this is equal to 1 plus 0.3 plus 0.045 plus 0.00045 plus 1. This is equal to 1.3 plus 45 by 10 raised to the power 3 plus 45 by 10 raised to the power 5 and so on. This is 1.3 plus 45 by 10 raised to the power 3 into 1 plus 1 by 10 square plus 1 by 10 4 and so on. And when you calculate the sum, you are getting it is 45 by 1000 into 100 by 99, and the answer we obtain it is equal to 1.3 plus this value we will have it is 45 by 990, and when you simplify this value, the answer you will obtain, these calculations these are shown over here, and the final answer you obtain that is equal to 74 by 55. Next is the sum of an infinite GP is 80 by 9 and its common ratio is minus 4 by 5. So it is given that the sum is 80 by 9 and the common ratio is minus 4 by 5. We have to find the first term. So it is given that 80 by 9 is equal to a over 1 plus 4 by 5. So this implies us that 80 by 9 is equal to, when you solve this value, it is 5a by 9. So this implies us that the value of a is equal to 16. So the first term we have it is 16. Next is the sum of first two terms of an infinite series is 15. So an infinite series is given. It is ar square, ar square, ar cube and so on up to infinity. And it is given that a plus ar is equal to 15. Next is each term of the series is equal to the sum of all the terms following it. it is given that a r raised to the power n minus 1, that is equal to the terms following it, a r raised to the power n plus 1 and so on up to infinity. So from this equation what we obtain, from this first equation we have a into 1 plus r is equal to 15. Now from this second equation we have a r raised to the power n minus 1 is equal to a r raised to the power n into 1 plus r so on up to infinity. So this term gets cancelled over here, we are left with r, this a gets cancelled, we are left with 1 is equal to r into 1 over 1 minus r. So this implies us 1 minus r is equal to r, this implies us 2r is equal to 1, and this implies us r is equal to 1 by 2. So if we substitute r is equal to 1 by 2 in this first equation, we will get a into 1 plus 1 by 2, that is equal to 15. This implies us a into 3 by 2 is equal to 15. This implies us that the value of a is equal to 10. So we have to find the series. So the series we obtain by substituting these values, a is equal to 10 and r is equal to 1 by 2 in this equation. So the answer we obtain it is 10. Next it is 5. Next it is 5 by 2. Next it is 5 by 4. Next it is so on up to infinity. So this is the infinite series that we obtain. Now the next question we have is the sum of an infinite geometric series is 8. So it is being given that a over 1 minus r is equal to 8. And its second term is 2. So a into r is given to be 2. We have to find its common ratio. So from this equation, if we calculate the value of r, we have it is 2 over a. We substitute this value in this equation and we will obtain a over 1 minus 2 by a is equal to 8. So this gives us, this implies us that a square over a minus 2 is equal to 8. This implies us a square is equal to 8a minus 16. So this implies us that a square minus 8a plus 16 is equal to 0. This implies us a minus 4 square is equal to 0, and this implies us a is equal to 4. Now if we substitute this value of a in this equation, we will obtain that the value of r we have it is 2 by 4 is equal to 1 by 2. This is the value of r that we have. So we are saying that the common ratio of the given geometric series is 1 by 2. Next is the sum of an infinite geometric series is 15. And the sum of the squares of these terms is 45. So we are saying a plus ar plus ar square so on up to infinity, it is given to be 15, and we know that this value is equal to a over 1 minus r. Next we have sum of their square, means we are saying a square r square so on up to infinity, it is given to be equal to 45, and this sum will be equal to a square over 1 minus r square. Now we have to find the series. Now from this second equation, we can write 45 is equal to a over 1 minus r into a over 1 plus r. So it is equal to 15 into a over 1 plus r. So we are having a over 1 minus r is 15 and a over 1 plus r is 3. Now if we divide both these equations, we get a over 1 minus r into 1 plus r over a, that is equal to 15 by 3 is equal to 5. A gets cancelled. So we obtain that 1 plus r is equal to 5 minus 5r. So we get 6r is equal to 4. So this implies us r is equal to 2 by 3. Now if we substitute this value in one of these equations, say in this equation, we will obtain a over 1 plus 2 by 3 is equal to 3. This implies us a over 5 by 3 is equal to 3. This implies us a is equal to 5. Now we have the value A is equal to 5 and the value of R is 2 by 3. This is the given series. So the given series we have, so the required series we have, it is the first term is 5, next is 10 by 3, next is 20 by 9, next is 40 by 27, and so on up to infinity. So this is the required series that we have. Next is if S1, S2, S3, so on up to Sp denotes the infinite geometric series whose first terms are 1, 2, 3, so on up to, and the common ratio that are given, it is 1 by 2, 1 by 3, 1 by 4, so on up to 1 by p plus 1. Then we have to show that the sum of these values S1 plus S2 plus S3 plus so on up to Sp, it is 1 by 2 into p plus 3. So we are saying the value of S1 we have, it is 1 by 1 minus 1 by 2, that is equal to 2. The value of S2 we have, it is 2 by 1 minus 1 by 3, that is equal to 3. Next S3 we have, it is 3 by 1 minus 1 by 4 is equal to 4. Continuing in this way, we have Sp is equal to p by 1 minus 1 by p plus 1. The answer we get, it is equal to p plus 1. Now we have to find the sum of all these values. We are saying it is 2 plus 3 plus 4 so on up to p plus 1, and the sum of all these terms, it is equal to p by 2 into 2 plus p plus 1. We have total p by 2 p terms, so it is p by 2 is there, and we are saying it is the first term is 2 and the last term is p plus 1. So the answer we are getting, it is 1 by 2 into p plus 3. So this is the value of S1 plus S2 plus S3 so on up to Sp. Now next we have is the sides of a given sphere is 10 centimeter. The midpoints of its sides are joined to form a new sphere. So in this figure it is being explained. We are saying we have a sphere and the sides of this sphere, they are of length 10 centimeter. This is of length 10 centimeter. Now the midpoint of this sphere, they are joined and we obtain another sphere. Then the midpoint of these are joined, we obtain another sphere. We are saying this process is continued indefinitely. Now what we have to calculate is, first thing is the sum of the areas. We have to calculate the sum of the areas, and second is the sum of the perimeters of the sphere. So we are saying that if this length AB, it is 10 centimeter, or this DC is 10 centimeter, then the length of this BE we have, it is 5 centimeter. This is 5 centimeter. So this length EF we are saying it is 5 root 2 centimeter. So we are saying this, the first sphere we have, its length is, all sides they are 10 centimeter. The second sphere we have, its sides are 5 root 2 centimeters. Now if we calculate the value of PQ, the length of this third sphere, we will have the length, it is 5 centimeter, because we have this length 5, the half of this is 5 root 2 by 2 square plus 5 root 2 by 2 square whole square. The answer we are getting, it is 2 times, this value is 25 into 2 by 4 square root. So we are getting the answer, it is 5 centimeter. So we are saying the squares we are talking about, they have the length 10 centimeter. Next we will have the length 5 root 2 centimeter. Next we will have the length 5 centimeter. Now we have to find the area. So for area we have the formula, it is 10 square, 5 root 2 square, then 5 square, and so on up to infinity. We are writing this is 100 plus 50 plus 25, so on up to infinity. This is an infinite GP. So the sum we have, it is A over 1 minus R, and the value of R we have, it is 50 by 100 is 1 by 2. So the answer we get it is equal to 200 centimeters. Next we have to calculate is the perimeter. So perimeter we have it is 4 into 10 plus 4 into 5 root 2 plus 4 into 5 and so on up to infinity. So the answers we get it is 40 plus 20 root 2 plus 20 plus so on up to infinity. This is an infinite GP and the sum of this GP it is 40 over 1 by root 2. So this is equal to 40 root 2 by root 2 minus 1. If we rationalize this term, we are writing root 2 plus 1 over root 2 plus 1. So the answer we get it is 80 plus 40 root 2 centimeter. This is the perimeter and this is the area. Next we have is each side of an equilateral triangle is 18 centimeter. So this side is given to be 18 centimeter and it is given that it is an equilateral triangle. Now midpoints are joined to form another triangle and are joined to form still another triangle. So midpoints are again joined. So we are saying that this length will be 9 centimeter. So what we have to do, we have to find the perimeters of all the triangle and area of all the triangles. So we are saying when we are calculating the sides of this triangle, we are saying this FBD, this is also an equilateral triangle. So the length of the side AB it is 18. The length of the second triangle, we are talking about FD, that will be 9. The length of the side IH, that will be 9 by 2. Now when we have to calculate the perimeters of these triangles, it is 18 into 3 plus 3 into 9 plus 3 into 9 by 2 plus so on up to infinity. If we write 3 common, we are left with this 18 plus 9 plus 9 by 2 so on up to infinity. The answer we are getting it is 3 into 18 over 1 minus r is 9 by 18, that is 1 by 2. So we are getting the final answer in the form, this is 3 into 18 over 9 by 18. When you solve this value, you will get it is 1 by 2. So the answer you will obtain it is 108 centimeters. This is 108 centimeters. Next is we have to calculate the areas of all this. So the area of the first triangle it is root 3 by 4 into 18 square plus root 3 by 4 into 9 square plus root 3 by 4 into 9 by 2 square and so on. We write root 3 by 4 common, we are left with this 324 plus 81 plus 81 by 16 and so on. Again this is a GP. So we are writing this is 3 by 4 into the value of A is 324 divided by 1 minus the common ratio we have it is 81 by 324. So we are getting it is root 3 by 4 into 324 divided by 1 minus 1 by 4. On solving this you will get the answer is 108 root 3 centimeter square. So this is the area, the sum of the areas of all these triangles. Next is after striking a floor, a certain ball rebounds 4 by 5 of the height from which it has fallen. Find the total distance that it travels before coming to rest if it is gently dropped from a height of 120 meters. So we are saying that initial height it is 120 meter. Now after it strikes the ground, it will go to a height of 4 by 5 into 120 meter. In the next step, it will go up to the height of 4 by 5 into 4 by 5 into 120 centimeter or meters. And this process will continue indefinitely until it comes to rest. So the total distance covered by the ball, it is 120 plus 4 by 5 into 120 plus 4 by 5 square into 120 plus so on up to infinity. If we write 120 plus 120 common, we are left with this 4 by 5 plus 4 by 5 square plus so on up to infinity, and this value is equal to 120 plus 120 into a over 1 minus r. So the value of a we have over here, it is 4 by 5 over 1 minus 4 by 5. This value we have, it is 1 by 5. This gets cancelled. The answer we obtain, it is 120 plus 120 into 4. So it is 120 plus 960, that is equal to 1080. So we are saying that the total distance covered by the ball is 1080 meters. Next is, if x is equal to, it is some cos 2n, cos raised to the power 2n theta, and n is varying from 0 to infinity. It means we are saying it is cos 0 theta plus cos 2 theta so on up to infinity, and the value of y is given to be, sigma n is equal to 0 to infinity sin 2n phi, and the value of z is given to be sigma n is equal to 0 to infinity cos 2n theta sin 2n phi, where it is being given that 0 is less than theta is less than phi is less than pi by 2. We have to prove that xz plus yz minus z is equal to x into y. Now clearly all this term we are saying this is a GP whose common ratio is cos theta. So sum of all these terms we are getting, we are writing x is equal to a over 1 minus r. The value of a we have, it is 1 over 1 minus cos square theta, 1 minus cos square theta. The value of y we will have, that is 1 over 1 minus sin square phi, and the value of z we will have, that is equal to 1 over 1 minus cos square theta sin square phi, and this is equal to 1 over 1 minus sin square theta into 1 minus cos square phi. Now we require the value of these two terms. So look at the value of x. We obtain 1 by x is equal to 1 minus cos square theta. So this is equal to sin square theta. So we are writing this is equal to 1 over 1 minus 1 by x. We look at this value, we will obtain that 1 by y is equal to cos square phi. So we are getting it is 1 minus 1 by y. So if we multiply these terms, we will get it is 1 over 1 minus 1 minus 1 by y minus 1 by x plus 1 by x y, and on solving this value we will obtain z is equal to 1 over, this 1 and 1 gets cancelled, we are left with this 1 by y plus 1 by x minus 1 by xy. So we can write this in the form, we are saying z is equal to 1 over 1 by x plus 1 by y minus 1 by xy. If we take the LCM, we are getting it is 1 over xy is LCM. We are left with is y plus x minus 1. So what we get is that z is equal to xy over x plus y minus 1, and this implies us that zx plus zy minus z is equal to x into y. We obtain this result. Now next we have is, if Sn is equal to this value, then we have to calculate the least value of n such that 2 minus Sn is less than 1 by 100. So Sn is given to be this. This is the finite sum we are talking about, and the value of Sn we will obtain. This is first term into 1 minus 1 by r raised to the power n over 1 minus 1 by 2. So we are getting the value of Sn is equal to, when you solve this value, you will obtain it is 2 raised to the power n minus 1 and divided by 2 raised to the power n and whole divided by 1 by 2. So we are getting it is 2 raised to the power n minus 1 over 2 raised to the power n minus 1. So on solving this, we will obtain Sn is equal to 2 minus 1 by 2 raised to the power n minus 1. We are getting Sn is equal to 2 minus 1 by 2 raised to the power n minus 1. So this thing implies us that 1 by 2 raised to the power n minus 1 is equal to 2 minus Sn. So we are writing 2 minus Sn is equal to 1 by 2 raised to the power n minus 1. Now the next question we have is, let x1 and x2 be the roots of the equation x square minus 3x plus is equal to 0 and x3 x4 be the roots of the equation this, and it is known that the numbers x1 x2 x3 x4 in that order form an increasing GP. We have to calculate the value of A and B. So it is being given that they form the GP. So we have x1, then x2 is equal to r times x1, x3 is equal to r square times x1, and x4 is equal to r cube times x1. And as these are the roots of these equations, so x1 x2 are the roots of this first equation. So what we obtain is that x1 plus x2 that is equal to 3 and x1 into x2 is equal to A. From the second equation we have x3 plus x4 is equal to 12 and x3 into x4 is equal to B. So we have these equations. Now if we substitute the values in these equations, we will obtain x1 plus r x1 is equal to 3 and second we get is r x1 square is equal to A. In the second case we are getting r square x1 plus r cube x1 is equal to 12 and r raised to the power 5 into x1 square is equal to B. We have to calculate the value of A and B. So from this first two equations, we are writing, from this equation we have x1 into 1 plus r is equal to 3. From this second equation we have x1 r square into r plus 1 is equal to 12. So if we substitute this value over here, we will obtain r square into 3 is equal to 12. So this gives us r square is equal to 4 and this implies us r is equal to 2, because it is being given that they form an increasing GP. It is being given they form an increasing GP. So we are not taking the value of r as negative. So we are getting r is equal to 2. Now if we substitute this value of r is equal to 2 in this equation, we will get x1 into 3 is equal to 3. So this implies us x1 is equal to 1. So the terms we obtain by substituting these values in this equation, it is the first term it is 1, next it is 2, next it is the value is 4, the next value we have it is 8 and the next value x4 value we have it is 32. But we are not interested in these values, we have to calculate the value of A and B. So if we substitute these value of x1 and r in these equations, we will obtain the values of A and B as 2 and 32. Now next we have is, suppose A, B, C are in AP. So if these three numbers they are in AP, it means it is being given that 2B is equal to A plus C. and a square, b square, c square are in GP. So it is given that b square is equal to a square, b square whole square is equal to a square into c square. Next is, if 0 is greater than b is greater than c and a plus b plus c is equal to 3 by 2, we have to find the values of a and c. Now from this first condition, if we assume that d is the common difference, then what we will have is that a is equal to b minus d and this c is equal to b plus d. So if we substitute these values in this equation, we will obtain b minus d plus b plus b plus d, that is equal to 3 by 2. This d gets cancelled. We are left with this b is equal to 1 by 2. We obtain the value of b is equal to 1 by 2. So what we get is that the value of a is 1 by 2 minus d and the value of c is 1 by 2 plus d. Now these are the values of a and c that we have. Now if we substitute these values in this equation, b raised to the power 4, we are having b raised to the power 4 is equal to a square c square. So we get b square with plus minus sign, that is equal to ac, and this implies us the value of b we have, it is 1 by 2. So we are writing it is plus minus 1 by 4 is equal to 1 by 2 minus d into 1 by 2 plus d. So this is equal to 1 by 4 minus d square. So this implies us that d square is equal to 1 by 4 plus minus 1 by 4, and we are getting this is equal to 1 by 2 or 0. Now the value of d cannot be equal to 0 because d is the common difference over here. So the value of d is not 0. So what we are getting is that the value of d we have, it is plus minus 1 by root 2. The values of d we have, it is plus minus 1 by root 2. So if we substitute these values of d in these equations, in the values of a and c, we will obtain the answer for a and c as, these are the values we are getting. A is 1 by 2 plus 1 by root 2 and the value of c is 1 by 2 minus 1 by root 2. So these are the values of a and c that we will